algorithms are there, classification, and what are the algorithms are there in regression. One fast. Should by heart those algorithm names. Whenever it's very basic interview questions. Be getting during interview. So what are the regression algorithms and the classification algorithms? I have
Sir,
already.
logistic regression algorithm, KNN
Okay.
classifier,
Okay.
classification,
Okay.
support
KNN, sir.
vector mission, sir. Navy
Okay.
based algorithms, decision tree classifier,
Okay.
and the random forest. In regression, linear regression, KNN regressor, and support vector regression,
Okay.
decision tree, and XGB boost.
Don't
booster.
worry about those boosting algorithms. Next, it will come. So first, we should understand these algorithms. So when it comes to the classification algorithms, logistic regression is one of the algorithm which we already discussed, and opposite to logistic regression, linear regression, which we will be using for regression. Same scenario, k nearest neighbors, we can use it for classification and regression both. And the same scenario, support vector machines, we can use for classification and regression both. And naive Bayes, we can use it only for classification. We can't use this naive Bayes for regression. And next algorithm is decision tree. We can use it for classification and regression both. Same scenario, random forest classification for classification and regression both. This is how you need to explain whenever if any interviewer asks you what are the algorithms are there in classification and regression. Simply, you need to start with, okay, so logistic regression we can use for classification and linear regression we can use it for regression. Next thing is k-nearest neighbors, we can use it for classification and regression both. Same scenario, support vector machines we can use for both. And the decision tree, we can use it for both. And the random forest, we can use it for both. Naive Bayes, we can use it only for classification. That is how you need to explain during the interview. You should remember all these algorithm names. And next, see the same scenario. In the regression algorithms, all these algorithms comes under the linear regression only. So simple linear regression, multiple linear regression, polynomial regression. These three things also we already discussed. Next thing is simply support vector regression, decision tree regression, and random forest regression. So this is how these are all the algorithms you should remember. See the differences. This Java T-Point is very good blog for the beginners to understand basic machine learning, whether it's a machine learning or Python or Java, whatever it is. You just need to select it and you just need to read the blog. So you should make a habit of reading the blogs and you should understand. See, here it's clearly explained. Regression algorithm, classification algorithm. In regression, the output variable must be of continuous nature or real value. So in classification, the output variable must be a discrete value. Discrete value is nothing but zeros, ones, twos, three, like that. The task of the regression algorithm is to map input value with the continuous output. See, the input value is nothing but x. X could be any number of columns like x1, x2, x3, something else. And output is only one variable. Same thing, the task of the classification algorithm is to map the input value with the discrete output. So here we are mapping with continuous value. Here we are mapping with discrete value. Regression algorithms are used with continuous data. Classification algorithms are used with discrete data. So in regression, we try to find the best fit line which can predict the output more accurately. So here also we can predict the discrete values more correctly. So in classification, we try to find the decision boundary which can divide the data set into different two classes. Like this. So regression algorithms can be used to solve the regression problems such as weather prediction, house price prediction, etc. Weather prediction is continuous value like 30 degrees, 40 degrees, 70 degrees, 20 degrees. Next, house price prediction. Simply, what is the house of the price of that house? For example, if there is any real estate company is there, that real estate company, they will build a ML model to predict their prices. So whether the house price is 50 lakhs, 40 lakhs, 30 lakhs, something like that. Same scenario, classification algorithms can be used to solve classification problems such as identification of spam emails. If you open any one of your mails, you will be having a folder of spam. See, these promotions. This Gmail, by default, they will be maintaining ML models behind it. So after seeing these mails, they will simply classify. So these messages they classified into promotions, and some mails they classified into social, and some mails they classified into primary. And same here also, they would have they classified into spam also. So here I don't have any spam messages like that. That is what it is mentioned. Speech recognition, identification of cancer cells, all these things will come under this classification. See, the regression algorithms can be divided into linear and non-linear. Same, we already discussed. The linear regression is the linear algorithm. Remaining algorithms are non-linear algorithms, like decision tree is non-linear algorithm, and random forest is non-linear algorithm. Next, the same scenario, the classification algorithms can be divided into two, that is binary classifier and multi-class classifier. So like this, you should remember the concepts one by one. So for example, if you want to read about any algorithm also, this Java T-Point will explain very clearly. So let us see one by one algorithms. So class. So now let us start with this logistic regression. We have already discussed. So if you want to explore more about this, what is classification and what is logistic regression, you can just read about it. Don't depend upon only my session. Don't depend upon the only theory whichever I have provided. Here what it is, email spam detector. So class A, let us suppose class A is no spam. So class B is spam. So all these messages, it was able to divide into class A and class B. So if you are divided into two class, that is binary class. If you are divided into three class, that is multi-class. Simple. See, everything we discussed already in the computer. Binary classifier, if the classification problem has only two possible outcomes, then it is called as binary classifier. Yes or no, male or female, spam or not spam, cat or dog. All these things will come under the binary classifier. Next, same with the multi-class. As it is, in the binary, we will be getting 2. In the multi-class, we will be getting more than 2. It's not limited to 3. It can be anything, whether it could be 10, 15, 20, 25, 30, whatever it is. So classification of types of crops. So crops, how many we will be doing? So classification of types of music. For example, in the music, we will be getting multiple like melody and folk and some other musics like that. So in the learnings, this KNN algorithms and logistic regression will take time, and so it will take time to train the model. It will take time to learn the patterns. That's why these are called as the lazy learners. So KNN algorithms and logistic regression. And eager learners means it will learn quickly and it will understand the patterns very quickly, and the processing time of these algorithms is very fast. So that's why this decision trees and naive Bayes and this ANN will come under the deep learning, that is artificial neural networks. Next, types of ML classification algorithms. We already see these things. These two are the linear models. You should understand, you should remember these algorithms. Logistic regression and support vector machines is the linear algorithms. And when it comes to nonlinear algorithms, these are all the algorithms coming under the nonlinear models. So k-nearest neighbors, kernel SVM, naive Bayes, decision tree classification, random forest classification. So kernel SVM is nothing but advanced format of support vector machines. Don't confuse. So support vector machines, if you are trying to use it for nonlinear things, that will be called as kernel SVM. Nowadays, Bayesian tree classification, random forest classification. Next, evaluating a classification model. So to evaluate the classification model, we will be using all these performance metrics. So the first one is log loss or cross entropy loss. This is the first one. So we have already discussed this log loss. So whenever the coefficients are updating in the logistic regression, this log loss we will be using as a measurement to get the best coefficients. And next, confusion matrix. We have seen the confusion matrix and we have discussed what is true positives, false positives, true negatives, and false negatives also. So this is the confusion matrix. And next performance metric is AUC ROC curve. In the real time, we won't be using that much this AUC and ROC curve. If you have more interest, you can just read the blogs related to this AUC and ROC curve. These two are important. So log loss and cross entropy loss. Both will be same. Use cases of classification algorithms. See the differences. Email spam detection, speech recognition, identify cancer tumors, drugs classification, biometrics identification. So if anything coming like yes or no, positive or negative disease, what is the disease the person is having? All those things come under the classification. So now, if you want to read more about the logistic regression and the step-by-step process of this logistic regression, you can read it here. You can read it clearly. I'm just leaving it for you guys. Just read it and understand. So this is the example they clearly provided. So all these are input. This is the target variable. So whether the person is purchased or not. All these are independent variables. This is dependent variable. So data pre-processing steps they have mentioned, train test splitting they have mentioned. So I'm suggesting everyone, if you get in, if you're stuck anywhere during the interview, if you find any new interview question, if you want to learn more about the theoretical of algorithms, you can refer this Java department. So this is one of the blocks. So we do have other blocks like medium towards data science and analytics vidya. All those blocks, we will get a clear explanation about machine learning concepts and machine learning algorithms and the pre-processing steps. Everything you will get there also. And now let's move on to the KNN algorithm. So KNN algorithm is nothing but K nearest neighbors algorithm. So this KNN, we can use it for classification and regression both. We can use it for both. So for example, this is our data set before KNN algorithm. And now this blue color point is there, right? So this is light blue, and like let us suppose this is green color, and this is blue color, and this is yellow color. And this is related to class A, and this is related to class B, that is class 0 or class 1 from our perspective. So this data point I want to predict by using the K nearest neighbors algorithm. So to predict that, I need to check with the nearest neighbors. So for this point, let us see what are the how many neighbors are there. So if I am taking K value as 3, I need to calculate with the 3 neighbors. If I am taking K value as 5, I need to check it with 5 neighbors. If I am taking K value as 10, I need to check it with 10 neighbors. So let us see. Let us see how it will for example, column 1, column 2. Which is target. So column 1, let us suppose column 1 value is 1, column 2 value is 2, target is 0. So same scenario, column 1 is 2, column 2 is 3, target is 0. Let us suppose this is 5, this is 6, this is 1, 8, 9, this is 7. So this is 5, 3, 6, target 0. 8, 5, 3, 1. So like this, you do have multiple inputs of data. So when my column 1 and column 2 like this, so here my target is 0. That is, let us suppose class name or class 0. So this is one is class. So the k nearest neighbors, k is the number of neighbors which we need to take. So how many nearest neighbors we will be taking, we should concentrate on this. So for example, I have taken k nearest neighbors, 3 neighbors I have taken. I have taken k nearest neighbors as 3. I trained my model by taking k nearest neighbors as 3. Let us suppose I got a new data point like this, 2.4 and 3.4. Normally, by seeing this, so here we do have very less examples, and to compare this, by seeing this, we can say this data point is related to class level 0. By default, we can say that. Why? Because here our examples are very less. But what if my data set is huge? What if my data set is having lakhs of rows and millions of rows? In that way, in that scenario, what I need to do? I need to train a model. So this k nearest neighbors, what it will do? It will try to calculate the distance between 3 neighbors, nearest neighbors. So for this 2.4 and 3.4, what are the 3 neighbors we will be having? So this 3, this is 2, this is one of the neighbor, this 2, 1, 2, 2, 3, or you can consider 2, comma 3, or 2.2, comma 3, 2.8, comma 3.8. So these 3 points, it will calculate the distance. Two data points. So here, what are the two data points? 2.4, comma 3.4. This is our prediction. This is our data point which we need to predict. And first, what it will take? It will take this one. 2.4, 3.4, and 2 comma 3. 2 comma 3. So everyone knows the distance between two data points is square root of x2 minus x1 whole square x2 minus x1 whole square plus, here don't confuse with the y. So let me take another thing. So this is x1, x2. This is y1, y2. Let us suppose, let me take this 2.4 and 3.4 as, if I take it as y, it will confuse. So this is y1, z1. This is z2. Yes. So, so it will calculate the distance between these two data points. This incoming data point, that is whatever the thing I have highlighted in red color. This thing, z1 minus x1 whole square plus z2 minus x2 whole square. That is the formula. But normally the distance between two data points formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula. So it will calculate the distance and it will tell this class related to 0. Okay, this data point related to class 0. And next, same second data point. So second data point is 2.4, 3,4, and let us take this one. 2.8, 3.8. 3.8. So it will calculate again the distance between these 2 points and it will predict this one also as 0. And next, same again, it is trying to calculate distance between 2 points. So let us suppose my third point is this one. Let us suppose it has considered this as the neighbor 5, 6. So here 2.4, 3.4, and here the point is 5, 6. So in this example, it has predicted the distance between these two is nearby. That's why it's my model may confuse. So it has predicted this as 1. But the k nearest neighbors having the facility, it will take the majority vote of all these 3. So what is the highest majority? Two zeros is the highest majority. Finally, KNN will predict class 0 for the new incoming data point. So whatever the data point here it is coming, right? So it will predict this one as 0. So this is 0. That means class A, it will predict. That is how this KNN algorithm will work. So let us suppose if I take k value as 5. Normally in the k nearest neighbors, we will be taking odd values only. We can't take even values. Why? Because if I take even values, let me suppose if I take k equal to 4. So first one predicted as 0, second one predicted as 0, third nearest neighbor predicted as 1, fourth one 1. So here ambiguity is there, right? So it can't predict. So there is no majority, clear majority, 50-50 it is coming. So we can't predict. That's why always it's better to take the odd number in the k nearest neighbors. So for example, if I take k equal to 5, first one 0, second one 0, third one 1, fourth one 1, fifth one 0. So finally, it will predict class level 0. That is how the KNN algorithm will work. So whatever the steps I have explained, the same steps it will be coming. So the KNN working can be explained on the basis of the below algorithm. So now select the number of k of the neighbors. That is k number we need to select. So either we can test it. First you can try with k equals to 3 and you can check the accuracy. Next you can try with k equal to 5, you can check the accuracy. K equal to 10, you can check the accuracy. Like that. Or else if you want to do in the automated way, you can just take all the k nearest neighbors in the for loop. You can test wherever you are getting good accuracy. So next what we need to do, calculate the Euclidean distance of k number of neighbors. Whatever the distance we have calculated, right? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That formula by default is KNN algorithm will use behind it and it will calculate the distance. So next step is take the k nearest neighbors as per the calculated Euclidean distance. So among these k neighbors, count the number of data points in each category. So whatever the data points I have explained here, right? So 0, 0, 1. So if I'm taking k equal to 3, 2 of them related to 0 and 1 of them related to level 1. So next, assign the new data points so that category for which the number of neighbors is maximum. That is what we have mentioned, the majority voting, right? So for which we do have the number of neighbors. So class 0 is having highest neighbors. We can predict that as class 0. If the class 1 is having highest neighbors, we can take it as class 1. For example, if here I have taken one data point. Let me take another data point. So 5.5, comma 6.5. In this example, what I will get? 1, 1, 1. Synonymously, I got all the classes as the 1 when I took k equal to 3. So like this, the classification algorithm will assign the new data points to that category for which the number of neighbors is maximum. So next, our model is ready. See the clear explanation it is giving. Suppose we have a new data point and we need to put it in the required category. Consider the below image. So these are all my data. These are all my data related to class 1 and class 2. This is my new data point. So here what they have considered k equal to 5. We will calculate the Euclidean distance between the data points. Is the distance we have already studied in geometry. It can be calculated as, see the formula. Euclidean distance between a1 and b2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This formula we have already seen in our school time so many times. So here k equal to 5 I have taken. For this data point, the nearest neighbors are, these 3 are nearest and these 2 are nearest. So it will calculate the distance and the majority voting is from this green color point. So now my new data point will classify as class A, that is category A. So category A is having 3 neighbors and category B is having 2 neighbors. So 3 is the majority one. That's why our new data point also we will be predicting the best. We will be predicting as the class A. So how to select the value of k in the KNN algorithm? As we already discussed, we need to test with multiple k values. There is no particular way to determine the best value for k. So we need to try some values to find the best out of them. The most preferred value for k is 5. First, we will start with 5. Then you can increase it to 7, 9, 11, like that. A low value for k such as k equal to 1 or 2 can be noisy and lead to the effects of outliers in the model. So it can lead to outliers. So large values of k are good, but it will take time to do the training and it will take time to do the processing. It will take time to do the calculation. So for example, whenever I have taken k equal to 5, it will do the distance calculation 5 times. What if I take k equal to 20? It will calculate 20 times. For example, if k equal to 5, so for example, if it is taking 5 seconds, if I am taking k equal to 25, it will take 25 seconds. It is a very high time, like that. So it's better to avoid higher values. So the disadvantage of KNN, it is always we need to determine the value of k. It will take a lot of time and we need to put a lot of manual efforts. So this Python implementation for this KNN algorithm, the same thing will follow for the regression also. Let us see the example for regression. So the same example, the same thing, it will take for regression also. The only difference is in the target, you will be getting in the place of classes, we will be getting continuous values. So 20, 30, 90. So here in the classification, it has taken the majority vote of 0, 1. But when it comes to the regression, it will take the average value of all the predictions. Whatever the predictions we will be getting, the model will predict average value of all these 3. So for example, distance between 2 data points, 2.4 and 3.4 and 2, 3. So for 2, 3, where it is, yeah, 2, 3, what is the value here? 30 we will be getting here. So in this example, 2.8 and 3.8, here it is 38. So here in the third one, 5, 6, it could be 60. So for at the final prediction, finally KNN will predict average of those three predictions. Simple. When it comes to the classification, it will do the majority voting. When it comes to the regression, it will take the average. Average means 30 plus 38 plus 60 divided by 3. That is 30 plus 38 plus 60 divided by. So here we do have taken 3 neighbors. So that's why it calculated 3. If you take 5 neighbors, it will calculate that. So 30, 38 plus 60 divided by 3. So 30 plus 38, 68 plus 60, 128. So 128 divided by 3. So 128 divided by 3 means value is 3 4 42 point something. So the 42.6, let us suppose. So this is my final prediction for this one. So for this, my model, KNN model, predicted this as 42.6. This is regression. Same scenario with if we take 5, it will calculate 5. If I take 3, 10, it will calculate 10. Nothing important. You will be getting lot of algorithms. Okay, we don't need to go through each and every algorithm. Why? Because it will take a lot of time. We need to put a lot of efforts. So first we should learn what are the important algorithms and all those things. In the algorithms, it has imported k nearest neighbors, sklearn dot neighbors, import k neighbors classified. So in the neighbors, we need to provide neighbors equal to 5. So in the metric equal to Minkowski is nothing but this is the distance metric. We do have multiple distance metrics like Minkowski is one of the metric, and another distance metrics like Euclidean, all those things. We can use it. Anything we can use. So this is the explanation related to the KNN algorithm. So whether it's classification, the step-by-step process is same. Whether it's regression, the step-by-step approach is same. The only difference is in the classification, it will take the majority vote of all the nearest neighbors, and in the regression, it will take the average of all the nearest neighbors. Nothing more than that. So now let's move on to the naive-Bayes classifier. Let us see what is naive-Bayes classifier. Naive-Bayes classifier simply works on the formula called Bayes theorem. So in our school time, we do have a theorem called Bayes theorem. So this Bayes theorem. So by using this Bayes theorem algorithm, this naive-Bayes algorithm will work. So naive-Bayes algorithm is a supervised learning algorithm which is based on Bayes theorem and used for class-solving classification problems. Excuse me. It mainly used in text classification that includes a high-dimensional training data set. So we can use any algorithm for text classification, but this naive-Bayes is the preferable. As compared to naive-Bayes, this random forest and decision tree also will work very well. So naive-Bayes classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that make quick predictions. Why? Because it will be taking probability value of each and every class. So how much probability the class is related to, that is 50%, 60%, 80%, like that. So some popular examples of naive-Bayes algorithms are for spam filtration, sentiment analysis, and classifying articles. All these things we can use it. So in interviews, you will be getting this question also. Normally, this naive-Bayes algorithm is having two words. Sometimes the interviewer may ask, what is the meaning of name and what is the meaning of days? We just need to we just need to tell the definition. So it is called naive because it's assumed that the occurrence of a certain feature is independent of the occurrence of other features. That means each and every feature should not depend on other feature. So for example, this column 1 is one feature, this column 2 is another feature. If I have more columns, column 3, column 4, like that, each and every feature should not depend on other. That means it should not be having correlated to each other. That is the meaning. It is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other features. Such as if the fruit is identified on the base of color, shape, and taste, then red spherical and sweet fruit is recognized as an apple. Here, each feature is individually contributes to identify that it is an apple without depending on each other. So, for example, if you want to tell one particular image is apple, what we need to say? The color of the image, the shape of the image, the taste of the image, and whether it's spherical or circle, all those things we will be considering. Each and everything is one feature. Like fruit is having multiple features like color, shape, size, weight, all these things. So each and every feature is independent here. In the same way, if I want to tell one person is male or female. So for example, normally male will be having less hair and face cut is different and his body strength is different, height is different. When it comes to the girls and female, the face cut is different, the hair is high, so the height and weight, the length will be different. So here each and everything is one feature. For example, height is one feature, weight is one feature, length is one feature, hair length is one feature, color is one feature. So here all the features are independent of each other. That is what we need to sell. That is what we need to tell. So it is called naive because the naive Bayes algorithm assumes that the occurrence of each and every feature is independent of the other features. We can take this example also, we can tell it. So in the logistic regression and linear regression, we do have some assumptions. In the same way, naive Bayes also, this is one and only important assumption. But if you take this example, in this example, this feature is independent. Sorry, this is dependent on this one. See, almost if it is increasing, this is also increasing. If it is increasing, this is also increasing. But in the naive Bayes, it should not be like that. Each and every feature should be combined to finalize the prediction. That is the meaning. When it comes to the Bayes, it is called Bayes because it depends on the principle of Bayes algorithm. This naive Bayes algorithm, whatever the naive Bayes classifier we are using here, it is working on the formula of this Bayes formula. This Bayes theorem formula is probability of A when it is B equal to probability of B when it's related to A and probability of B and probability of B. Bayes theorem is also known as Bayes rule or Bayes law, which is used to determine the probability of a hypothesis with prior knowledge. It depends on the conditional probability. So it's completely using the probability formula itself. Normally, this P of A by B is called as posterior probability and P of B by A is called as likelihood probability. So P of A by B is nothing but probability of hypothesis A on the outside. This thing you need to read. The assumption of this naive Bayes algorithm you need to read. Nothing more. So working of naive Bayes classified as usual, the working nature is same, everything is same. So here we have taken so it will calculate the probability of each and every feature. So it will calculate all this. So whether it's rainy, sunny, overcast, all those things, it will calculate the probability value and it will predict. So which class it is related. So whether it's related to, so for example, here we are trying to predict the weather forecast. So whether it's the sunny, overcast, rainy, all those things. Here we can use this naive-Bayes algorithm. So simply what we need to input? We need to input naive-Bayes classifier, and we can use that naive-Bayes algorithm on our data set, whatever we do. So now in naive-Bayes also we do have multiple types. So let us see the types in naive-Bayes algorithm. So here also I have provided the explanation. You can follow this, or you can follow this Java T point also. Anything you can refer. So in between below also I have referred this towards data science blog. You can refer this blog also. It's better. You should start reading the blogs. You should start listening more YouTube videos, all those things. And next types of naive-Bayes algorithms is Gaussian naive-Bayes algorithm. So when characteristics values are continuous in nature, then assumption is made that the values linked with each class are displaced according to Gaussian, that is normal distribution. So if the data is following normal distribution, then I can consider this Gaussian naive-Bayes. And next, multinomial naive-Bayes. So multinomial naive-Bayes is where we use, that is multinomial distribution. That is whenever we do have text data, so in that scenario, we can use multinomial naive-Bayes. Each event in classification constitutes the presence of your word in a document. So in the NLP, each and every word is like one dimension. So in that perspective, we can use this multinomial naive-Bayes. And next, Bernoulli naive-Bayes. So here multiple distribution it will form. Multinomial distribution it will form. When my data set is following. When my data set is following normal distribution, I can use this Gaussian naive-Bayes. Why? Because Gaussian distribution and normal distribution both are same. When my data set is having multinomial distribution, I can use this multinomial naive-Bayes. Same scenario. When my data set is a Bernoulli distribution, we can use the Bernoulli naive-Bayes. So if we have multiple features, more features, we can use based on our requirement. We can use multiple any type we can utilize. So these are the pros and cons. So it will take time. Why? Because we need to calculate on each and every probability of each and everything, right? So it will take time. So these multiple examples I have provided here. Yeah. So here we just used Gaussian naive-Bayes. You can just take this and you can execute this thing. And if you want to read more documentation about this naive-Bayes algorithms or those things, you can go through the scikit-learn. You can open this and you can read it. So Gaussian naive-Bayes, multinomial naive-Bayes, Bernoulli naive-Bayes, all those things. You just need to focus on the assumption. That is fine for you guys from interview point of view at least. Why? Because nowadays we are using completely latest algorithms. So we are not using this. This is the very old algorithms like linear regression, logistic regression, KNN, naive-Bayes. All these are old algorithms. Nowadays, everyone using random forest and deep learning algorithms, and we do have pre-trained models. All those things we need to learn a lot. So we need to concentrate on all those things. And next, so naive-Bayes is completed. So the next thing is support vector machines. Support vector machines is simply the extension form of the logistic regression. In the logistic regression and linear regression, what we will be doing? We will be finding the regression line. This is the regression line normally. This is the line which we will be using to divide class A and class B. But in the support vector machines, apart from this line, it will be having support vectors also. Whatever the dotted lines here, right? This will be called as support vectors. That means with the help of these support vectors, the margin will be high. So here it will be having high margin. Here also it will be having high margin. So by using this, it will be able to predict the it will be able to predict the class labels correctly. That is the only advantage. And the SVM kernel trick is one of the things. In the SVM kernel trick, what it will do, it will try to, so for example, this is normally linear data set. This is linear data set. We can easily classify them into two classes by using the regular support vector machines. But in the kernel tree, if it is non-linear data also, we can, by using this SVM kernel tree, we can divide the classes easily. That is the example. So linear SVM is used for linearly separable data, which means the data set can be classified into two classes by using a single straight line. Then such data is termed as linearly separable data, and classifier is used as linear SVM classifier. So for example, what it is meaning, if a data set can be classified into two classes by using a single straight line, then such data is termed as linearly separable data. You need to explain this whenever the interviewer asks, what is the difference between linearly separable data and non-linearly separable data? So if a data set can be classified into two classes by using a single straight line, then such data is called as linearly separable data. Okay. And the same thing, if we cannot do that, that will be called as non-linear data. Let me show you the non-linear data examples. See, this is linear data. We can divide it. This is below also non-linear. This is below also linear. See, this is non-linear data. Normally, this is green color data is class 0 and this blue color data is class 1. That is circles related to one class and the triangles related to another class. So how I need to identify? So here I can't draw any straight line. Here also I can't draw. It will mix up. It can't do the predictions. So for that, what I can do by using the kernel trick concept in support vector machines, I can predict it. So what it is doing here to make it, so it is squaring one data point and adding the another data point. Whenever I'm doing like this, so whenever I do this z equal to x square plus y square, so all the green color points came below and all the blue color points came up. See the difference. This is the, normally this is called as the feature engineering. This concept will be called as, this is your data. What they are doing, let us suppose. So yeah, I do have -1, -2, -3. Fine. 2, 8. So for example, here my target feature is like, so this is all the negative values related to 0. This is just assumption. All the positives related to class 1. So what I'm doing, when I printed this in the, line, when I printed this on x-axis and y-axis, like this, I got the data like this. Let us suppose I got the data, all the green color, all the zeros are green circles. So next one is blue triangles. All of them are blue triangles. When I use the scatter plot by taking this x and y axis, I got data like this. So for this data, I can't do what I can do. I can't do use any linear regression. I can't use any linear SVM model. Why? Because it will give wrong predictions to me. So next, what I am doing, I have used feature engineering concept. Like what I'm doing, x square I am doing. X square x square I'm doing. Once if I do x square, what it will do? It will convert into 1, 4, 9, 25, 16, 64. Now see the difference. Now I am able to easily differentiate both of them. This will be called as feature engineering. So this x I am converting into x square. Or you can, in the place of x square, you can multiply with x into minus 1 also. X into minus 1 also you can do. If you do x into minus 1, what it will do? So this thing will convert into the positive, and again this thing will convert into the negative. So to overcome this issue, what I did, I just did square. This is one of the feature engineering technique. So this type of feature engineering will be happened in the kernel SVM. That is the logic behind regular SVM and kernel SVM. So in the kernel SVM, it will convert the data points into the high dimensional data, and it will try to predict the points correctly. That is the only difference. For linear SVM, we can use for linearly separable data, and kernel SVM, we can use it for nonlinear data also. So kernel SVM, we can use it for linear data, because if the model is working for nonlinear data, it will work very well for linear data also. The only problem is if one model is working well for linear data, it won't work on the non-linear data. That is the problem. Okay, hope everyone clear till support vector mission. Whatever. So hyperplane is nothing but one so multiple planes will be there. So one is nearby positive class and another one is nearby negative class. Nothing more than that. So below also I have given example for support vector machines. You can just go through it and you can execute the code. These are all the algorithms. The algorithms we can discuss. So it is able to classify. So this is the classes. So this is red color points and black color points. Still some points are coming in red color zone. That is some negative zone. That is wrong zone. It may happen with the linear thing. So in the linear, what we have, as we can see, the above output is appearing similar to the logic regression output. In the output, we got the straight line as hyperplane because we have used a linear kernel class line, and we have also discussed about that for the few displays. The hyperplane is straight line. So in the test data also, some wrong predictions are there. This is wrong. 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 This red color is wrong. All these things are wrong predictions. So these wrong predictions we can overcome by using the kernel SVM. That is the difference. So basically, the support vector machines is designed for classification algorithms only, for classification problem statements only. So it will work very well on the classification algorithms. So till now, we have covered Bayesian regression, linear regression, and KNN algorithm, and support vector machines we have covered, and naive-Bayes classifier we have covered. So if you want to learn more about this, what is linear regression and Bayesian differences, see the interview questions will be getting like this only. So during next session, we will discuss about this Bayesian tree classification and Bayesian tree regression. Why? Because this Bayesian tree and random forest both are important algorithms. So that's why I'm keeping this for separate session. So these are regular algorithms, but this Bayesian tree and a classification, whatever the XGBoost, tagging, all those concepts we will be discussing tomorrow. So that's why I kept this algorithm for separate session. So if you want to read about difference between linear regression and logistic regression, just see how it is clearly explained. So in the linear regression, simplest pipeline. But when it comes to the logistic regression, this is S curve, that is sigmoid function. This S curve is nothing but sigmoid function. So you should remember all these points. You just read and you just make a note of all these things. You just need to make a note of all these things. Okay, clear everyone? Any doubts? If you have till now, you can ask them. Tomorrow we will be discussing decision tree, random forest, and what is bagging, what is boosting, all those things we will be discussing. So once this decision tree, random forest, and boosting algorithms, and what is bagging and what is boosting is completed, next we will move on to the NLP. So in NLP, I will be explaining one or two projects, one or two projects I will explain. So remaining remaining one project I will give for assignment. So please refer each and everything I have mentioned here. I am sending this blog also, this blog link also, this Jupyter notebook. I will just save it. See all the multiple blogs I have mentioned. You will be getting a lot of blogs. Just go through these blogs and read it. Then you will get more knowledge. Just download this file and you can refer this Java T-Point also. So you will get everything here. So in the Java T-Point. So whether it's related to Python internet questions, whether it's related to machine learning internet questions, whether it's related to data pre-processing, whether it's related to classification, regression, clustering, whatever it is, everything they explained clearly. You can refer anything. All these are important blocks on it. So you should make a habit of reading blogs to become a data scientist. That is what I can say. Clear?